Welcome, everyone. Welcome to this AWS Stockholm Meetup at Klarna. Thank you very much, Klarna, for having us here. My name is Gunnar Grosch. I'm one of the co-organizers of the meetup. We also have Rolf Koski. He's one of the co-organizers of the group. I think that's the only one here besides me. Welcome. This is the agenda for tonight. We're going to start off with Case presenting a bit about Klarna. And then we're moving over to Jesper doing a presentation on building a DevOps platform for regulated workloads. And then we'll have a short break, about a 15-minute break, before we turn it over to Attila, who will talk about the journey from general to service-specific WAF implementation in the development pipeline. And then as a bonus session tonight, we'll have Rolf Koski presenting on how his team from Cybercom won the Deep Racer competition at the AWS Summit in Stockholm. So with that, I leave it over to Case.
Cool. Thanks. Thank you all for coming. So I am Case Tainter. I'm the Director of Developer Services here at Klarna. And I've been at Klarna for like 7 years and started as an engineer. And now we have this domain name Developer Services. And what we're actually trying to do is leverage a lot of AWS services to be able to build secure and reliable services with a minimal amount of effort. And one of the things for here at Klarna that we believe in, is the ability for us to iterate quickly is actually what makes you successful. And Jesper will talk a little bit about what things have been slowing us down in this regard. But basically, like if we actually are trying to look at over time how much time we've been spending on infrastructure, it has grown significantly as a percentage of the total company. So we've been looking at ways in which we can actually be using AWS to leverage this so that people can be spending a bit less time as an individual on infrastructure, but also get a much better product on the a much better product out of that. And I think that the key, like 3 key things on that is actually being obsessed with your customer on who you're actually building it for, and then enabling autonomous teams in our case, and then focusing on tooling and automation. So at Klarna we have like something around 200 teams. We have like 1,000 engineers, and focusing on trying to obsess about what people want and how we can serve them better is certainly challenging. But we also, like in actually building tools, we try to think about how can we build these in a way where we don't take away ownership of what people are doing. We're just making it kind of fit into their workflow and making it so that they can not have to think about the more complex things, but still feel like that what they have built is still their responsibility to run, because that has something that kind of ends up slowing down a lot of banks. So we'll start with Jesper to talk about like how we've looked at a deployment platform in like a regulated banking space, and then after the break, Attila will talk about how we've integrated something like WAF into our whole into this platform, so that we can get the benefits of WAF without some of the drawbacks that you might get from a typical way of implementing it, where like something is failing and one team ended up setting it up and it's failing and they don't notice it, and the other team things aren't working and they don't notice it because they never set it up. So that's hand it over to Jesper. Thanks.
Hello. All right, so let's check this out. So my name is Jesper Söderlund. I work as an architect within our developer services domain. So today we're going to talk about a project or initiative that we've been working on for a while now, and that we are quite proud of and see as a big sort of investment for us going forward in the future. Okay, so first a little bit about our journey, what we've been doing and what led us down this path, and what we have been achieving in the past as well. So Klarna started quite a long time ago. I think it was 13 years ago, something like that now. And we started off with building a big monolith in Erlang, and it's still around, still doing the super important work within Klarna. But we have sort of complemented that over time with some other sort of microservices, also moving some stuff to the cloud. And nowadays we are pretty much at the end of the year, at least 100% in the cloud, even with a wide sort of microservices distributed architecture. So of course that will also have some impacts on our teams, like how do we organize ourselves as a company. And so one or a few fewer people in a few sort of cohesive teams in the beginning, and now we have this sort of plethora of different teams organized in various different ways and different domains and different business areas. But it also has had impacts on our technology stacks. I mean, Klarna has been on a technology journey over the last couple of years. In the beginning, it was very sort of homogeneous. We had like Erlang as our sort of core technology stack, but over time, when we branched out to all these kind of microservices and complemented with other different functionalities, we sort of let the teams develop their own sort of technology stacks or selected the technology in their stacks basically, and that over time has led to quite a wide variety of different technologies used within Klarna. But it also has led to quite a big sort of variety of different ways to both operate and deploy different things in Klarna. And that is, of course, quite costly. I mean, it's like a lot of time that is invested in these kind of tools and technologies and not operational systems to have services running in a smooth fashion, right? So. And also, Klarna has been on the journey from developing quite a lot of new services and new features in our core services that has required us to achieve even higher levels of regulated workloads and compliance checks and those kind of things. And Klarna received a banking license a couple of years ago, and that has also introduced yet another set of requirements to Klarna as a business. And of course, that puts a lot of constraints and requirements on all these kind of requirements, or all these varied systems and different technology stacks that we have been achieving at that time. So, did it stop working? No, still working. Okay, so what would like a standard bank do about this situation? Have a lot of different systems, a lot of different teams, a lot of different technologies, a lot of different ways to operate and do these things. And I think all companies have come to this point, or larger companies at least, have come to this point at some point. And the way to get a control of this and make sure that that you are fulfilling all these requirements on security and compliance and those kind of things is basically try to lock it down, like to get something. The less you change, the more control you have, right? Kind of like the old mentality. So getting something through kind of this kind of maze of different things to changes and getting fixes to be done could be almost impossible. And at Klarna, we were not. We were trying to be better. We had tried to be agile. We moved into the cloud to be more agile. But still, we invested in shared tooling and shared functions in Klarna. But we had the kind of reasonably sort of a standard mentality of like we had tickets. It took quite a long time to get a change out of production, even though each individual step, and we were running on a quite flexible agile platform itself. Oops. Yeah. Okay. So it still kind of led to a bit of frustration among our developers, and so getting first infrastructure, then networking, and security, and operation, and monitoring, and everything should have their part of the flow. Like each of these different parts, we tried to automate. We had like tools and teams for these different things. So reasonably flexible, but still a bit of frustration. Okay. So how do we want to solve it the Klarna way to not be like a standard bank? Okay, so at the end of 2017, our CTO, Koen, he came up with this sort of the vision for us. So we want to go from basically from nothing to deployed service in less than 1 hour. And that is not just getting things out there. It's easy, just throw it up there, deploy it, open up the security groups to the world. Hey ho, you're live, right? But the point of doing this within less than 1 hour is to, with all the quality controls and all the security and all the compliance checks and all that thing. So I would say that before or to get to this point, there was at least weeks to get to this point before. So this is kind of like the vision we've been working on now for a while. Okay, so some of the key parts that we wanted to get across and want to focus on in this with this new initiative was to focus on the developer experience, like getting it to be very smooth for developers, like leveraging shared platforms and technologies to have them not to invest a lot of time and effort into building these kind of operational systems, the metrics, the monitoring, the deployments, and those kind of things. And of course, also like efficiency-wise, and also one of the major driving factors was like security, like raising the security level when you have such a distributed landscape with hundreds of microservices, hundreds of teams, and getting them all to implement a certain new compliance requirement or a new security requirement can be quite a nightmare. You have to run around getting each and every all of those teams to actually implement that new requirement, which is very, very hard. So if we can invest in a common platform that will sort of, we can invest in that platform and raise the level for all people at the same time, all people running on that platform. It's kind of what our idea. So, and also having a shared common standardized platform increases the capabilities to have control and a good view on how you're doing from a compliance perspective. Alrighty, so what do we sort of aim to give the teams? At least this is at least some of the core parts, and there's many more details underneath the surface here. But a way to build your software, to deploy your software, to logging and monitoring and auto scaling, security and compliance checks, and code scaffolding and all those kind of things. So basically, we'll try to get something that out of the box can give a development team starting out. To reach this vision of having 1 hour from getting a hello world through all the compliance and security checks and deployment and in a safe way out into production. It's kind of like our overall vision. Okay, so what did we do? First of all, we then started with a big domain model where we sort of modeled up the domain in different sort of logical parts, and then sort of, okay, how do we want to achieve this domain model, this kind of rough sketch of an architecture? So we did a lot of technology evaluation and selection, and some of the sort of key factors in choosing technologies was we want to have managed services, we want to have highly secure services, we want them to be flexible and extendable so we can modify the behavior where we need it, and sort of where the base services did not provide all the functionality that we needed. So a bunch of different things here. We evaluated things and we come up to basically this kind of rough outline of what kind of things we are using. So as you can see, we are using the sort of the runtime aspect here. We're using ECS, load balancer, auto scaling groups, those kind of standard AWS technologies. It is well integrated with AWS ecosystem from a tight security constraints point of view, so we can have a tight ingress and egress controls of the stuff running there, and also we get the support of managed services from AWS. From the build and the construction side of things, like the build pipeline part, we choose Concourse as our sort of build pipeline. Concourse is a quite modern CI/CD system based around Docker, so it's very extensible, and we felt that it was a good fit, kind of a good scale-out capabilities and those kind of things. On the deployment pipeline side, which is basically taking like an image and getting it out into production, we have started to use code pipeline from AWS for that part. We pretty much the type of workload that we're focusing on in the first phase here, at least, is running with Dockerized workloads. So we're not supporting yet the sort of serverless applications built into in our pipeline or in our tooling right now. However, we did select to use the serverless stack with lambdas, API gateways, step functions, and DynamoDB and those kind of technologies for the tooling of the actual platform itself. For in those cases, we don't have the strict needs for like the poor long tail latencies that those kind of technologies can see. In our deployment tooling, we felt that was an acceptable trade-off for getting the benefits of managed service and those kind of things. All right, and then we also have some other services. We're using Splunk and for logging, and S3 for logging as well, Datadog for metrics, and Snyk for security scanning, Bitbucket for code management and those kind of things. So a lot of these things were already existing at Klarna. Some things were brought in new as part of this project, but some things we are also running outside of this, inside of Klarna, like Jenkins is our current core CI/CD pipeline system for like self-managed managed workloads or pipelines. Okay, so what does a sort of deployment look like inside of this platform that we call Code to Customer, or C2C? So we in our domain model, we modeled up something we call this lifecycle stage. So we have from staging, performance, playground, and production. These are four different lifecycle stages that we have for support. So for each of these stages, we do a deployment where we have like a number of different steps, and each of these steps are orchestrated with some CloudFormation templates and some tooling around orchestrating the flow of different things through step functions here. So we're creating security groups, then we go into some AWS infrastructure, like the load balancers and those kind of things, and permission stacks, and then we sort of have a concept of canary releases that we've implemented on top of ECS. So we do a canary release, and then we wait for a canary promotion event. That can be like different types of events, like metrics or automatic or manual sort of confirmation over the canary. And then we sort of roll out the production version to the rest of the cluster, and then release the canary back to zero, basically. Okay. So inside of our containers, we schedule, if you know ECS, it consists of something called tasks. So a service consists of tasks, and the task consists of containers. So in ECS, we have selected to run like the service container here, like that's what really the teams provide. And then we, as the deployment platform, we provide a number of tooling and sidecars around that to provide additional functionalities. So we use AWS task networking or VPC networking in ECS, so we can have this kind of strict ingress and egress control rules for the different individual tasks. So they do have identities when they talk to other things like databases, so you can have a strict ingress control there. Yeah, and from the service here, the team will only need to focus basically on the service. It has access to like SSM parameter store for like secrets and configuration things, and or S3 bucket for other things. And if it connects to databases and stuff, that's currently running in a different account, so we can have access that through the VPC peering connections between accounts. So in this account where we're running this stuff, it's only running the platform stuff and the service containers from the developers. We also have a concept called an Egress Proxy. So all the outgoing traffic from the service will pass through an Egress Proxy. And when external traffic, I then mean like things targeted for the internet. Like if you're targeting another internal service, that goes directly across the VPC networking. So, but if you have access to the internet, we want to have a whitelist and control over what you access. So it's forced to pass through an Egress Proxy. Righty, okay, yep, tooling stack, these kind of serverless technologies from AWS. Okay, so what about the regulated part? I mean, I've talked about this as building a platform for regulated workloads. So a lot of focus on security and being able to prove that you have achieved or done certain things in your in your operations. For example, one of the key things is like security updates. So both security updates of the Docker images and the AMIs or the VMs that it's running on. Vulnerability scanning, both of code and of the actual images and the operating systems and those kind of things is super important as well. So we're providing ingress and egress security, as I talked about previously. Auditability, we have auditability in the platform. We also have worked on hardened OS security images on top of what the basic AMIs are provided from Amazon, so we've added security on top of that, and we've added so we can have encryption everywhere. So even from the load balancer to the instances, we do have encryption in transit at that point as well. Alrighty, so we're going to dive into a bit deeper on some of these things when Attila talks about WAF later on. Okay, so I'm going to dive in a little bit on one of the, or a couple of the things here as well. So the AMI updates. It sounds like an easy thing, just build a new AMI, update the cluster, and it's done. But if you want to do that in a very secure and robust fashion, we come up with a quite good process, we think. So basically, we have a build pipeline where we build the AMI, and in that we run inspec security check rules, and we we do like a local canary testing of like making sure that it starts and like you can run a single service on it. But then we also go ahead and propagate it through our pipelines. So we test it in different test clusters to make sure that we can deploy a service, that we can update a service, that we can delete a service, that it works for all kind of basic use cases inside of the ECS cluster. And just when it's past that, we do go over to the promotion part. Then we actually copy it out into the different account where it's going to be used. I didn't mention that from the beginning, but we are setting up in a multi-account and multi-region kind of fashion. So it's a quite big platform if you look at the complete footprint. And then when we actually update a cluster, we do that in a blue-green kind of fashion. So we have a cluster sort of backing an ECS cluster is 2 auto-scaling groups, one blue and one green, or called ASG1 and 2. And then we update the new AMI to one of the autoscaling group that is shrunk down. We sort of scale it up, launch a canary in that part to make sure that it's actually running, and then we sort of drain the instances of the old autoscaling group, and then when that is done, the old ECS has to reschedule the task onto the new autoscaling group with the new AMI, then we can shrink it down, and then the platform update is done, basically. So all these kind of steps is quite elaborate, and there's something we take care of as part of as part of the platform. If you have more questions about that, you can ask Johan, as it's up there. So he's the one that did most of it. So yeah. Okay, so cool. And also something we've added is actually to be able to prove that we are actually in compliance with things. So we've added monitoring on the AMI age and also Docker image age in the platform. So we can actually alert and visualize that we are in compliance with with our sort of SLAs that we've set up for the AMI updates. Alrighty. Did it break it? I think it's kind of coming and going a little bit.
Close to your mouth.
Yeah, but hello. Yeah, okay. I'll eat it. Yeah. Alrighty. Okay, so the next part that I'm going to talk a little bit about is our Egress Security. So the Egress Security is something that we set up so that we can have control over the outgoing traffic. Basically, the scenario is kind of thought like this, where you have like an evil hacker on the internet, kind of manage to find some exploit in the service, and then gets into the service, but he then wants to extract his data. Right? So he wants to get the data out into to his server. He wants to contact his control servers or whatever. So, but in this case, when you deploy a service, you have a metadata manifest, so they're specifying what kind of domain names or connections you're allowed to make. And then since we force everything not on the local IP addresses through the proxy, and then we have a squid proxy that kind of checks it against the metadata that was deployed for the service, that is actually not matching that, and if it doesn't, it sort of blocks the traffic. So that is an additional level of security that we have added as part of the platform here. And also when it comes to Egress Security, we have a sidecar running next to the service on the actual ECS cluster next to the service, and that kind of decides whether it's a local or remote or external traffic. So if it's a local traffic, it kind of routes it directly across the VPC, so we don't have any egress rules for the local IP addresses in the clusters, but then it's the ingress rules on the connecting side is a strict sort of ingress security rule there. And also on the ingress security rule from the other side, kind of you can specify logically, saying that I want this logical service to be allowed to call myself, instead of having to fiddle around with knowing exactly what the security group ID and those kind of things is taken care of by the platform. All right, so some of the things that we have learned, and some of the wins that we have achieved over this project. So we are heavily using CloudFormation, and we found that we have maybe a little bit too heavily used CloudFormation in some cases, or at least we haven't. We could have found a better trade-off between what is the deployment unit that we put inside of a single CloudFormation template. Just to give you a little bit of scale, we have maybe the complete tooling platform consists maybe 100 20 stacks or something like that, yeah, in that order. So, so it's quite a fine-grained sort of model. So we thought that we wanted to have like a fine-grained model because we wanted to deploy only like specific changes to, and not have to deploy a lot of changes in the same time. But it turns out that actually CloudFormation, when you have that many stacks, it takes quite a long time to deploy actually. So when we first started this, before we started optimizing it, it took like 30, 40 minutes or something like that to make a deployment of the new software release. Yeah, so that could also be improved with tooling and stuff like that, and we have improved it quite significantly. But that's something to think about when you start off these kind of things. We could have been benefited from having larger deployments units, like larger CloudFormation stacks, instead of having many, many small ones. Another thing, I mean, when we did the technology evaluation and stuff, it's we realized this quite early on, but it's still good to really drive that home that it's important if you have compliance requirements or security policies in your organization. It's very important to look at what sort of compliances are covered by certain services. For example, we would have loved to have used Fargate, for example, for ECS. We are using ECS on EC2, as you noticed previously. But Fargate does not support like encryption of local disks in Fargate, and that's something we have as a policy. We need to have encryption at rest for everything, so we could not use Fargate. So that's the reason we went down the ECS ECS on EC2 route. Yeah, and also like pipelines from day one. Maybe we did a POC with the project, and then we started off the project proper once it's sort of the proof of concept was demonstrated, and we got approval. But we didn't. Then we started. Okay, we're in such a hurry. We just start developing, and we should have maybe spent some more time up front in the project than to actually start to develop the pipeline, so we can start with that from day one. And now we've had to retrofit that afterwards, and it's a bit more painful. So that's something we learned over this. Start eating again. Okay. So yeah, that's something we could have done better. Oh, okay, and also another thing that we also learned painfully part of the way through the project is that to multi everything. Like we started off in this way. Actually, we started off with a multi accounts and multi region, but then we sort of got lazy, or we thought that we didn't really. Yeah, I don't really know why, but we stopped doing that anyways. And then we discovered like quite a bit later that okay, now we really need to have some sort of new features that we've added in a multi-region, multi-account kind of fashion, and we've had to we had to do some quite rushed changes to make that happen basically. So when you do like a multi-account, multi-region, multi-platform, then it's really important that your development cycle is also very tightly integrated into that deployment pattern as well, because there are some limitations in some services. There's some things that only work within a region. There's some things that don't really work quite well between accounts, or you need to set up the policies at least between accounts in a certain way, and those kind of things. So it's important to get these things and the proper structure in place. So local development is not always the best thing in this case. Also beware of limits. I mean, limits are everywhere, as we all know, in AWS, and I think in all cloud environments. But it is important to check them all. I mean, we've had just the other day here, we ran into some new limits on the length of some identifiers that we hadn't thought was something we were going to run into. And yeah, so it's kind of important. The length of identifiers, like number of instances and load balancer, and those kind of things are maybe more obvious. But length of identifiers might be really subtle things that you don't think about, like how big can this name be that you take in from your users? How big can a service name be? And then you can hit the limit of number of characters in your stack names or your task definitions or whatever. So that's kind of an important limit as well. Alrighty. Okay. So, and also some of the wins I think we've achieved or seen in this platform in development of this platform is that like the collaboration across across Klarna and most of all maybe within developer services, but also with our first customers. It really takes like an organization to raise a platform. I mean, there are a lot of special skills and special know-how within the organization that that is really important, that we need to get into into the design and thinking into the platform. And it's impossible with these kind of complex systems for anybody to know everything. So you need to collaborate. For example, in this case with the platform here, we had a feature development team for the InfraSec from Attila is from, so it's kind of developed a lot of the security features as part of the platform. So we had a really good collaboration with that. And we want to extend that going forward as well to have more of a formalized way to have an away team where you can have another team provide resources and develop things inside of the platform to increase speed of innovation and speed of development. Yeah. Because at the end of the day, something will be one team will always be like a choking point and a throttle. And we at Klarna, we don't want to have two big teams. We have like a two pizza team kind of mentality. Not Swedish pizzas, so it's kind of too small, but yeah. Otherwise, American pizzas. Yeah. All right. Yep. So that's one good thing that we did, and another thing that I think we did good was to iterate and release often. I mean, we had an early adopter team that was really helpful in helping us fleshing out our bad ideas and get the good ideas strengthened. So we had them early on board to help us guide like through the user experience of some of our tooling and the CLI that we developed and those kind of things. So and push the points which we might have not thought about too much, but it was kind of super obvious for as a external development team. So that was very good as well. All right. So I think I'm done with what I wanted to say. So maybe time for questions if we have any. Yep.
You were talking about your cool. You were talking about your cloud platform and that you achieve compliance at the same time that you achieve flexibility and deployment speed and automation.
Yep.
I wonder, is Klarna running its platform as a hybrid platform? So is there parts to reach full compliant which are closed down on-prem, or is it a full cloud platform?
Yeah, we don't have any things that need to be on-prem for compliance. That's not an issue. We are like about the same time or maybe earlier than this. Our CTO he said like as a strategic initiative we should move everything that we have into AWS, like into the cloud for speed of innovation and like not be experts in running data centers basically. Yeah. So that process is ongoing. It should be done by the end of the year. So we are 90% there or something like that. So yeah.
So it will be full cloud and at the same time fully compliant.
Yes.
That's pretty impressive, isn't it?
Yes.
I think I'm a user of Klarna, and I think it's really amazing.
Yeah, yeah, that's what we think as well. We have a big initiative that's also like a thing that's for like compliance as code. I mean, we don't talk about that here today, but that's also another thing that we are working on to like have a compliance automatically checked to what are the compliance checks we need to have, and then run that as code when things are changing. So that's like the thing we're working on currently as well. Yeah.
Okay, I have one question. You were using containers extensively. Have you considered like any kind of serverless technologies, and what's your take on like being PCI compliant in regards of serverless, because it has like kind of the PCI model has kind of a lot of this networking and firewall and specific things that it refers there. So do you have any insight on that?
In this platform specifically, we're not using serverless for any of the like the workloads itself. We are using that for the tooling or orchestration platform. We do have other parts of the company that's using serverless, but I'm not willing to talk about that right now because I don't know the details of it. But yeah, but in this platform, we're not using serverless. We don't support that as a part of the platform right now. It is something that we're looking to add, but I don't have any strong insights into what you're asking specifically.
Okay.
Yeah.
Any more?
All right. Okay. In that case, we have a 50-minute break. Are we on time? I haven't really checked the time, but yeah. Okay, so let's have a 15-minute break. We're a little bit early, but you can take the beers and food out there, and we'll come back and talk with or until I will present or how we do with Egress Security in the WAF. Okay, thank you. I will try to